So around 21 students have joined. Okay, so we won't be waiting for everyone. They'll join eventually. Okay, right? So I hope all of you remember the concepts that we have studied in last class. Good afternoon, Pranjal. Good afternoon, OS. Tell me. I hope all of you remember the concepts that we studied in last class, right? Just raise your hand, everyone. Very good, right? Very good. So I hope all of you who went through the problems, okay, the examples, were able to solve all the examples. Tell me, except one or two, most of you might be able to solve at least 6 examples. Right, everyone? Yes? Okay. Rafin Krishna. Okay. So let's see. We will start with the revision. Okay. We will start with the revision. Right. Now, if we talk about the topics that we have covered in last class. So I hope all of you remember the topics that we have covered in last class. That is the basic definition of fluid, right? Okay, that we have already studied in last chapter, which is properties of solid. Okay, right? That if a layer of any object, right? Okay, on applying shear force, right? If it's tell me, if it's shifts, if it changes, okay, then it is not your rigid particle, it is not your rigid object, okay? Yes, got it, very good. So it does not offer any resistance to shear stress, very good. Then the some terms that we have studied was density, relative density, okay? So this is one basic problem based on relative density, okay? Right? So I hope all of you understood this. Then second term is pressure. We already know that pressure is equal to force per unit area. It is perpendicular force per unit area, right? So this all of you know already. The unit of pressure is Pascal, right? Which is 1 Newton per meter square, right? And the second unit is bar, okay, which is 10.5 Pascal. I hope all of you are aware of other units also, which is torr, right? Of sorry, centimeter of Hg, okay. Then atmospheric pressure we already know. So these are some terms that we have already studied in the previous chapters, okay. Okay, then we talked about the pressure exerted by any liquid, okay, the pressure exerted by any liquid at height h, okay. The formula was rho gh. So I hope all of you already understood these things, okay. Now if it is rho gh, which means as you go down the pressure will increase, yes or no, right? Okay. Now if the height is considered, think about it, if height is considered from the top, right? If we consider height from here, then I can say that as h increases, pressure will increase, yes or no, tell me, yes or no, right? But if you consider the distance from the bottom, okay, distance from the bottom, then I can say that as y increase, pressure will decrease, right everyone? Tell me, okay, right? Yes, so this is the basic concept, because here if you observe this, it is minus rho g, because the y that we have taken over here is from the bottom, not from the top, okay, right? So this is the pressure difference. So in this they have taken the distance from the bottom, doesn't matter, right? Because when we talk about the height, okay, usually it is taken with the top, okay, got it, right? So in this they have taken reference as bottom because it's just a reference point. So it doesn't matter if you are taking from the top or the bottom, okay, right? Now based on this we have some problems. Now we discussed that doesn't matter whatever the area is, the pressure is independent of the area. If 2 points lie on the same level, right, even though the area is different, the pressure will be same, yes, right? That is your Pascal's law. I hope all of you remember Pascal's principle, that the pressure change, right, will be transferred undiminished throughout the surface of the liquid if we have same liquid. That's it, right? Okay. Now, I hope all of you can solve this problem, question number 2. Okay. I'm assuming that all of you could solve question number 2, question number 3. Okay. Right? Question number 2, question number 3, all of you could solve. We have already discussed these problems, right? Or problem like these. Okay. Now, the question number 4 is comparatively better one. Okay. When you talk about question number 4, how many of you attempted question number 4? Tell me. How many of you attempted question number 4? Just tell me, guys. Raise your hand. See, right? If you guys found this problem to be difficult, just think about it. No, think about it, right? Basic concepts. When you talk about pressure, okay, think about pressure. It is your this height, yes or no? Tell me this height. Agree, everyone? Okay. Now, if you see about this, now this length is L. What about this length? Tell me, what is this length? Can you tell me this length, right? Suppose this is L dash. So can you see that? Okay, L dash is L sine theta. Yes or no? Tell me, guys. L dash is L sine theta, because this was a better question. Among all the four, this is the better question. You should have tried it. Okay. Now, okay, suppose the pressure over here is PATM. The pressure over here is PATM. It is given the pressure is PATM. What would be the pressure at A? Tell me, what would be the pressure at A? Don't you think that the pressure at, think about it, right? Just try to find the pressure at this point. So I can say that, okay, PATM pressure at this point is equal to pressure at A, right? Plus pressure due to this. But the length is this one, right? I hope all of you remember the height is this one, right? Which is rho G L dash, rho G L dash. Anyone have any issue in this? Tell me. Anyone have any issue in this? Now I hope all of you understood the concept, right? Now it is easy. Yes or no? Tell me. Now it is easy. Think about it, right? So here the density is rho 1, so it will be rho 1. Okay, so I can see that pressure at A, take this transpose, we will have PATM, I'll write it as P naught minus rho 1 GL sine theta. Pranjal, that's what I'm saying, right? When you talk about pressure, what is the basic definition of pressure? Think about it now, right? What is the basic definition of pressure? Pressure is equal to, this is based on the basic concept. It is F perpendicular by A or F parallel by A. Tell me. Think about it, guys. Right? It is F perpendicular by A. Na? So obviously we don't have to worry about this force. Right? Why we need to worry about this force if the pressure is F perpendicular by A? Right, everyone? Got this concept? Yes? Tell me. Pranjal, got it? Okay. And in same way, you can find the pressure on B. Okay, pressure on B, right? Yes or no? Tell me. Because when talk about pressure on B, so this will be because of this, it will have some pressure, and because of this also, it will have some pressure, and both the pressure should be equal. So that's why if we talk about this first, right? So we have pressure on B is pressure on A plus rho 3 GL. It is rho 3 GL sine theta. Now, when about this, it is PATM. It is also PATM. So PB is PATM plus this, right? Equate it, find the value of L sine theta, equate in this, you will get the relationship of sine theta. This is linear equation in one variable. Got it, everyone? Tell me. Think about it. This is based on basic concept, right? Even though, right? Even though it looks difficult, it was not that difficult. It is based on the basic concepts. What is the force? Either it is perpendicular or parallel. Got it? I hope all of you understood this concept, guys. Right? Very good. Now, side of the wall we have already derived, so I'm not going to do this. Okay, side of the wall I have already derived. I hope all of you still remember the concept. Okay, we have studied Pascal's law. Okay, the last concept that we studied in last class was Pascal's law. Let's solve one problem based on this. One problem based on this. Everyone, please try to solve question number 6. Everyone try to solve question number 6. If you have solved, very good. If you haven't solved, please try to solve question number 6. I hope all of you can easily use F1 is equal F1 by F2 is equal to A2 by A1, or F1 by A1 is equal to F2 by A2. I hope all of you can use this. Yes or no? That is basic formula putting getting. Yes. Right? And then there's difference in pressure also. That is also you have to consider, because both of them are not on the same level. That is the concept. Right, everyone? Okay. So only these two concepts that you have to apply. Okay. Right? Got it? Yes or no? Tell me yes or no. Tell me, because they are not on the same level, right? You cannot just say that the force will be equal, because there will be pressure because of this also, na? Right? So you have to equate the pressure of this level and this level, right? Then assume the pressure to be on this level, right? Okay. Now, question number 7, we have done problem like this. Okay, right? Okay. Now, I hope all of you already remember this concept from the last class. These concepts. Okay, right, everyone? So we have covered topics till this point. Now, when you talk about fluids, we already discussed that fluid is divided into two parts: fluid statics and fluid dynamics. Fluid statics and fluid dynamics. Now, when you talk about fluid statics, right? Fluid statics, I can say that the concept that we have studied till now is first Pascal's principle. Okay, right? Tell me. And the second is, tell me, is there any other concept that we have studied, right, in this class or in any previous class? Think about it. Because when you talk about fluid statics, right, it is the property of fluid at rest, as simple as that, right? At rest. Now, is there any other property that we have studied? Tell me. There's a very famous property that we have already studied in class 9. What was that? Tell me, what was that? Message everyone. Everyone try to message. Archimedes principle and buoyancy. Very good, right? So I can say that, okay, if I have to divide this topic into fluid statics and fluid dynamics, right, then the fluid statics will comprise of Pascal's principle and Archimedes principle. Okay, and then again there's a derivative of problems, right? For example, when you talk about Pascal's problem, okay, right, or when you talk about Archimedes problem, we can mix mechanics and think about lots of problems. Okay, for example, when you talk about this case, when you talk about the case of pressure due to rho gh, we have already uh, saw that if we change the type of problems, for example, if we change the setup, right, from a stationary object to a accelerating object, right? Now, in that case, the whole container is moving, right? It's not that liquid is moving, right? So that will still comes under fluid statics, right? Okay, so I have studied, right, what would be the height, right? What would be the angle if a body is accelerated, right, or is uh, rotating and all those things. So these things we have already covered, yes or no? The angle and all those things, right? Got it? Yes or no? Right, everyone? Okay? Yes. So today we will be covering Archimedes principle, right? So I hope all of you already gone through this. Okay, right? Got it? So see, this was the second method which I was talking about, right? I hope all of you remember. This was the second method which I was talking about. by creating the forces, right? And this was the method, right? Depending on the pressure, right? Which was done in the sheet. Okay. Now, this is one problem which I hope all of you have solved because it is basically formula putting getting. Now, the topic that we are going to start today is Archimedes principle. Now, think about it. Okay, because we have studied this concept in class 9th. Let's see how much of you, sorry, how many of you remember the concepts? Tell me, what is Archimedes principle? And anyone, tell me, what is Archimedes principle? Think about it, guys. What is Archimedes principle? Anyone? Yes, I got one answer. Okay, right over. So over said a force experienced by a body is equal to weight of the fluid displaced by it. Okay, or even if we don't remember that, I can say that if any object is immersed in any liquid, it will experience some upward force. Yes or no? Tell me, right? And that upward force will be, as Ovash said, will be equal to the weight of fluid displaced by the object, right? Got it? Yes, Samarth. Got it? Yes or no? As simple as that. Yes or no? Right? Keep it simple. Keep it as simple as that, right? Because there's no other concepts which we haven't studied in class 9th. The same concept we are revising. Okay, so I can say that if I'm having an object, think about it. If I'm having an object like this, right? So if I'm having an object, I can say that the Archimedes principle say that, okay, that liquid, if any object is immersed in your liquid, then the liquid exerts a thrust, okay, on the sides, on the surface of the container, right? Or on the object. Yes, got it? Now, why is it so? Because if you try to understand the basic concepts, just think about it. Suppose we have a container over here. Suppose I'm having a container over here like this, right? And it is filled with water. Suppose it is filled with water. Now, can I say that suppose if it is filled with water like this, okay, this is filled with water. Okay, so can I say that if I immerse any substance in this, suppose I immerse this substance, right? This is your substance which I immersed. Okay, now tell me what, this is point A, this is point B. Will the pressure at point A equal to pressure at point B? Think about it. Will the pressure at point A be equal to pressure at point B? Yes or no? Just tell me. Yes or no? Obviously no, right? It is not equal. It is wrong. It is not equal. Not equal, right? So what can I say about pressure at A and B? Can I say that, okay, pressure at B is greater than pressure at A? Yes or no? Right? Means when you talk about this object, okay, if it is having some height, so we have pressure from this direction, pressure from this direction, pressure from this direction, and pressure from this direction. Okay, but pressure on this point is less than the pressure on this point, right? So I can say that force on point B by area is greater than force on point A by area, right? Got it? So can I say that, okay, force is more in this direction, right? Okay, so there must be some kind of force which is balancing this. Yes or no? Got it? Right? So that is your upthrust. See, this is your upthrust force. Yes or no? Tell me, guys, yes or no? Okay, got it? Yes, Yes. Now, as I said, as Owen said, and as all of you know, that the formula or the force, a thrust force, is basically, right? Basically what? Tell me, force by the, tell me, displaced liquid, yes or no? Yes or no? Right? And we know that force is equal to mass into gravity, mg, right? And suppose the liquid is having density rho. So what is the mass of the liquid? Tell me guys, what will be the mass of the liquid? Mass of the liquid will be rho into V. Yes. But when we talk about volume, this volume is volume, right? Displaced by the solid or volume displaced by the object. Yes or no? Tell me. Volume displaced by the object, right? So if I just club this, can I say that, okay, the upward force, right, or thrust or buoyancy or buoyant force is rho Bg, where rho is the density of the liquid, right? It is the density of of liquid. V is the volume of displaced liquid, of displaced liquid, and G is the acceleration due to gravity. Now, I hope all of you already studied this and it is a refresh to the concept that we are studying in class 9th. Anyone have any issue in this? Tell me, anyone have any issue in this? Think about it. If anyone have any issue, please let me know. Or all of you understood? Tell me guys, all of you understood this? Right? I hope all of you understood this concept. Yes or no? Tell me, yes or no? You just have to remember two things, that the density is not of this object, density is of the liquid. Second, the volume is not the volume of the object, it is the volume displaced by the object. Okay, right? For example, if it is not totally submerged, then the volume displaced will be less than that of the volume of the object. Yes or no? Tell me, right? So these things you should remember. Okay, so I can say that, okay, how can I say that a body is submerged, not submerged, partially submerged, right? Now think about it. We know that F upthrust. Think about F upthrust or buoyancy force, right? Buoyancy force is rho liquid, volume displaced by object, right? Into G. Got it? Yes or no? Tell me. Yes or no? Now, just suppose this object. So I can say that this object have a force which is mg in downward direction and an upward force which is buoyancy, right? That's your free body diagram, right, everyone? Okay. So can I say that, okay, let's see what is happening over here. So suppose if in this case the force is balanced, right? So I can say that, okay, rho L V displacement G is equal to mg. What is mg? Now this mass is density of an object, V volume of object, G. Yes or no? Tell me. Yes or no? Think about it. Right? So Gg will cancel. So I can say that, okay, density of liquid into volume displaced is equal to density of object into volume of the object. So can I say that? Can I say that, okay, if density of liquid is greater than density of an object, if density of liquid is greater than density of an object, right, then the object will always float. Yes or no? Tell me. Yes or no? Right? Because if this should be equal, right? If rho is more, right? This Vd is always less in order to make it equal to rho not V naught. Yes or no? Means the object will always be partially submerged. Got it? Yes or no? See how easy this concept is. Try to think like this. How easy this concept is. Yes or no? Right? because sometimes they just give you the density and it intuitive, right? For example, when you talk about anything, oil on water or ice on water, right? This is the concept, right? The density is less of the object as compared to that of the liquid. Now, I'm talking about the density. I'm not talking about the mass. Remember the concept. I'm talking about the density, right? So I can say that if density of liquid is greater than density of the object, it will always be, right, either float or submerged, right? Float or submerged. Got it? Tell me, yes or no, right? But if density of liquid is less than density of object, then the object will sink, right? Then the object will sink. Anyone have any issue in this? Tell me, anyone have any issue in this? Step by step, I'm taking it step by step. Any issue in this? No? Raise your hand, everyone. If you don't have any issue, please raise your hand. Okay, very good, everyone. Right? Easy concepts. Okay. Right. So this is what we just discussed. I hope all of you already remember the concept. This is what I just discussed. Right? Rho v is equal to Vd, where small v is the density of, sorry, small, this rho is density of liquid, the small v is the volume displaced. Okay, got it? So this is the concept that I just covered. This is the concept that I just covered, right? So if I can say that if it is partially submerged, if it's partially submerged, then according to your free body diagram, okay, total force is given by this mg in downward direction, right? Okay, and then upward direction if it is submerged. Got it? And this force, okay, this force is called as your apparent weight. Makes sense, na? Makes sense, right? Yes or no? For example, when you are in water, right, you feel light. Agree? Yes or no? You feel light, you feel comparatively less weight, right? Suppose if I want to check my weight in swimming pool, I will be happy. Yes or no? Tell me. Because I'll weight less, right? And not to worry about overeating, because I can just say that okay, my weight is less inside the swimming pool. Yeah, but I'm not you. You will vanish. Okay, you still haven't gained some weight or what? I thought that in this lockdown everyone would have gained weight like me. Abhiram, that's good only. Okay, I was 52 till I went to college, right? So that's good only. I was 45 in my first year. Okay, so that's much better than what I used to be. Okay, don't compare me now though, right? So I hope all of you understood the concept of apparent weight. Tell me yes or no, right? Yes or no? Now think about it. Suppose think from the teacher point of view. What changes can I do in this, right? What changes can I do in this in order to make different type of problems? Because this is the same concept, right? That is the concept, right? We cannot include any other concept in buoyancy, but we have mechanics. Again, mechanics is like uh, it's like a big boss of all the physics, right? What we are using in class 11th. Okay, so if I want to increase the difficulty level of the problem, what I should do? Tell me, think about it. Think about it in this. Think. Can we do something with G? I hope all of you remember. We can do lots of things with G. Yes or no? Tell me, yes or no? Right? So instead of writing B is equal to, think about it. I'll just write like this. Instead of rho liquid, V displaced, G, I'll write a G effective. Don't you think this would be the correct expression for buoyancy? Yes or no? Tell me. This would be the correct expression of buoyancy, right? Right, everyone? Okay, try to solve question 5, everyone. Try to solve question 5. Take your time, try to solve question 5. Okay, it's easy. Try to solve it. I'll give you 1 minute. So try to solve question number 5. Okay, right, everyone? Take your time. Try to solve question number 5. Yeah, it's almost similar. Okay, I'll see. Everyone, please try to solve. Everyone, please try to solve step by step. Sorry, volume display the volume of object is given by density of object by density of liquid. As simple as that. Yes or no? Tell me. Yes or no? As simple as that. Right? Got it? Think about it. So this was fairly easy problem, no? This is fairly easy problem. Right? So it's almost close to 90%. Okay. Now, next question, everyone. Try to solve this next question. Try to solve this next question, everyone. See, physics is all about questions, right? Okay, when you talk about physics, the concept will be covered in 15 minutes, right? It's the application part you have to learn. Guys, think about it. Okay, let's see. Let's see, guys. Now, what is given? A plastic sphere floats in water with 0.5 of its volume submerged, right? Got it? Right? This same sphere floats in oil with 0.4 of its volume submerged. So 0.5 means half percent. This means 50%. Determine the density of oil in sphere. Now, don't you think that this is easy? Right? Think about it. Don't you think that this is easy? Same concept, right? Density of sphere by density of liquid is equal to volume of liquid by a volume displaced by volume of sphere. In same way, take the ratio in oil, right? And solve. Easy. Yes or no? Tell me. Right? Got it? See? Yes or no? Tell me. Easy? Right, everyone? Okay. Very good, Sanya. So I hope all of you understood this concept, right? Let's solve one more problem. Okay, one more problem based on this concept. Try to solve this concept. Yes, Abhiram. Try to solve this problem, everyone. Try to solve this problem. Everyone try to solve this problem. Okay. So all of you can see the problem here. A piece of an alloy is made up of two metals, A and B, right? Whose specific gravities are 11.1, right? And 7.4. The alloy weighs 96 gram in air and loses 10 gram when immersed in water. So obviously, right? Just try to figure out what is given and step by step. Try to solve step by step. Okay. Think about it. Try to solve step by step. Think about it, guys. Think about it step by step. I'll give you a hint. Okay, right? Try to solve step by step, one step at a time. Now think about it. It is an alloy, right? Made up of two metals, A and B. And think about a math problem. Okay, just think about a math problem, right? Specific gravity 11.4. What's the meaning of specific gravity? Tell me. What's the meaning of specific gravity? It is density of liquid, density of this metal divided by density of water. Yes or no? Tell me. Yes or no? Right? Okay, so that is given. The total weight of alloy given. Okay, suppose the weight of metal X is X. So what would be the weight of metal B? Don't you think it will be 96 minus A? Tell me yes or no? Or X, sorry, X. Yes or no? Tell me yes or no? Right? Now specific gravity is given. Mass we know. Can you find volume? Can you find volume of A and volume of B? Think about it. Yes or no? Tell me. Step yes or no? Step by step. Right? Okay. Now after finding total volume, okay, we know this, right? After finding total volume, we know this. Total weight loss is basically a buoyant force, right? Weight loss is what? 10 gram, right? And the buoyant force is this, volume into density of liquid, right? You can get the mass of the metal A and B. Now think about it. Was this very difficult? Ask yourself, right? Don't answer me, just ask yourself, right? What concept was lacking so that you could not solve this? Okay, just ask yourself, right? Try to find the loophole in your concepts, right? Which because of which you couldn't solve this, right? Okay, I hope all of you understood this. Raise your hand, yes or no? Yes or no, raise your hand, yes. Because these kind of questions will be coming in examination. Okay, I can cover the concepts within 1 hour. I can complete the chapter, right? But basically you have to solve the problems now, right? Try solving this. Try solving problem 8. Everyone, try solving problem 8. Read the question first, write the information, think about the concepts, okay, then proceed. Step by step, guys, step by step. Okay, so I guess all of you have already gone through the problem. Let's see step by step, right? Now think about it. A cubical block of wood 10 centimeter. Try to imagine the question, okay? In physics, try to imagine the question, things will be easier, right? Okay, right? So basically what is the problem? I can say that, okay, suppose we have this container. Okay, in container, it is given that we have oil and water. Okay, oil and water. Now, this is floating between oil and water with the lowest surface 2 centimeter below the interface. Right, so basically the interface is suppose like this. Above this we have oil, below this we have water. So this is floating like this, right? and this is you're given as 2 centimeter. If the height of oil and water column are 10 centimeter each, now this is also 10, right? And the height of this is also 10, 10, right? Okay, density of oil is given. You have to find what? Mass of the block and the liquid pressure on the lower surface of the block. Now think about it, right? If you think about it, I hope all of you understood the problem. Yes or no? Right? Now, if you think we have two different liquids, so if you have two different liquids, the volume displaced, right, is of two different liquids. So the buoyancy is the sum of two different liquids. Yes or no? Tell me. But don't you think that this will be the same, right? This will be the same. The concept should be the same. Why the concept should change, right? Tell me, yes or no? Tell me, yes or no? The concept should be same, na? Right? So if it is 10 centimeters, so 8 centimeters in oil, 2 centimeters in this. So we should have buoyancy because of this surface in oil and this surface in, tell me, water. So try to find it, try to find, so mg is equal to the buoyancy because of oil plus buoyancy because of water, as I said, right? Right? Tell me. So mass, you got it. And we know that the pressure is total pressure, na? So it's rho1 GH1 plus rho2 GH2, as simple as that. Got it, everyone? Tell me. Easy? Think about it. Got it? Raise your hand. If you got this concept, please raise your hand. Right? Okay, so these are the different types. What else can we do? Right? Suppose if I make this an accelerated motion, then what will change? Instead of G, we will have G effective. Yes or no? That's the only thing will change. Right? So let's try some problems based on that concept also. Okay, where G is changed. Wait, 1 minute. Okay, so we have covered this, right? Apparent weight we have covered. This we have covered. Yes, right. So buoyant force in accelerated fluids. So I said that the only thing that you will change is G. Instead of G, just use G effective. Okay. Now, if what direction? Think about it. If any object is moving in upward direction, right? So G will be what? Tell me. Right? G will be what? G effective is, I hope all of you know, G effective will be G plus and G minus depending on the concepts, right? So if any object is moving in upward direction, then it is G minus A. If it is moving in downward direction, then it is G plus A. Yes or no? Tell me, yes or no? Okay, right? This, you can solve. 12 also you can solve. Okay, try solving example 13 first, guys. Try solving example 13. Everyone, try solving example 13. This is a very easy question, right? But again, some people might use as direct formula. Okay, that's why. Think about it. Tell me. It's very easy, very easy. Okay, wait, if I'll show you figure. Okay, anyways, if I show you figure, then the solution will also be visible. Anyways, I hope all of you can solve this, right? I'll just show you the figure. Try to think. Try to think. This involves both the concepts, okay? Solving, guys. Now, first of all, you should start with free body diagram, right? If you draw the free body diagram, I hope all of you understood the problem, yes or no? Right? So if you draw the free body diagram, so I can say that this mass M will have downward force, right? Think about it. Downward force, which is mg plus tension, and upward force, which is buoyancy. Yes or no? Tell me. In first case, right? In first case, yes. When lift is stationary, got it? When lift is stationary, this is the balance force. Now, when lift is moving, so I can say that, right? We have acceleration in this direction. So instead of writing, yes, right? So we can have, we can have G effective here, yes or no? We will have G effective over here, yes or no? Got it? As simple as that. Okay, right? So what would be the equation now? Think about it. Can I say like this? Yes or no? Think about it. Yes or no? Tell me, guys. Okay, so f dash is f, yes. Okay, now if you think about it, I can just say that the mass is same, na? Mass is same. So, right, so f dash by g by a, which is g effective, is equal to f by g. Using this, we will get f dash as this. Now, using this, yes, right? Now, we can solve for T naught, because T naught will be, right? T naught is same for both. So we will be using this equation, the equation that we have found, this one, first one, okay, and this equation to solve for T, right? T naught. Got it? So T is equal to T naught, 1 plus A by G. Just put the value of f dash over here, right? Okay, you will get the value of T naught, because f will be in terms of T naught, yes or no? Tell me. Think about it, yes or no? Then it is just linear equation, one variable, or converting T in terms of T naught. Okay, guys, I think most of you are still confused or understood the problem. See, if lift is accelerated upward, if lift is accelerated upward, then G effective will change, right? Yes or no? Then the force experience will also change, right? We saw that, okay? So if force experience will change, right? If the buoyancy will change, because F and F dash is buoyancy, yes or no, right? Don't think, okay, from where this F and F dash came. F and F dash is buoyancy, as simple as that, right? Okay, got it? And if your density is not changing, your volume displacement is not changing, the buoyancy force will be in the ratio of G effective, yes or no, right? Okay, that's why I can write F dash is equal to this. And then this is your NLM, okay? I hope all of you got this concept. Tell me, guys, I hope all of you got this concept. Ready? Got it? Okay, try this problem, guys. Try this problem. Okay, the same type of problem, right? Instead of wire, I'll just replace with spring. Okay, then try to solve. Everyone try to solve this. Step by step, try to solve this. Try to understand the problem and try to solve this. Okay, so a cubical block of plastic of edge 3 centimeter floats in water. The lower surface of the cube just touches the free end of the vertical spring, just touches. Okay, it's not that it is attached, it is just touching this, right? So it means it is in natural state. Find the maximum weight that can be put on the block without wetting it. So you have to find the amount of weight that can be put on this without, right, touching this surface, or you can just find that how much weight it can put till it this topmost surface touches this liquid. Yes or no? Tell me yes or no. Right now, if this spring would not be there, then the upward force will only be buoyancy, right? But because of this spring, if it will go down, the spring force will also push up. Yes or no? Tell me yes or no. Think about it. Yes or no? Right? Got it? Now the first question that you should ask is, how can I know that how much volume of this block is inside the liquid? Right? That you can easily get from this now, right? The density ratio. Yes or no? The density ratio. Got it? Yes or no? Tell me yes or no. So we know that after, yes, if we have this density, I can find the volume displaced by water. Tell me, if you can find the volume displaced by water, right? So volume displaced by water is this volume, and total volume is given. What is total volume? 27 centimeter cube. Yes or no? Tell me. Tell me. Right? Now it is already given that the density of plastic is less than that of the water because it is 800 kg per meter cube, whereas for water it is 1000 kg per meter cube. So obviously it's this will be, right. This will have some portion here, right. And what volume? Since it is 80%. So what is 80% of 3? Tell me. What is 80% of 3? 2.5, right? So I can say that only 2.5, sorry, 2.4 is, tell me, 2.4 centimeter is inside the liquid, 0.6 centimeter above the liquid, yes or no? Tell me. Yes or no? Sorry, 0.6, what I'm saying, 0.6, right? So total force will be, total upward force will be because of compression of 0.6 as well as buoyancy because of 0.6. Yes or no? Tell me. Yes or no? Think about it. Got it? Got the concept? Tell me, guys. Got the concept? Right? I hope all of you understood the concept. Yes or no? Raise your hand. Yes or no? Okay, very good, everyone. Very good. See, if you understood the concept, right? If you know how to use mechanics, things will be easy, right? Okay. So I hope all of you can try the remaining problems, right? Try to solve the remaining problems. Okay, we will start the next concept. We will discuss all the examples. If there's any example which you couldn't get, right? Because there are some good examples which will take time. So spend some time at home and just solve examples. Okay, I'm not going to say any other things. Just try to solve examples of this as well as HCMA for next class, right? So we'll start next topic. So this is the end of fluid statics, right? Okay, this is the end of fluid statics. Okay, the next thing that we will be starting is fluid dynamics, right? Or hydrodynamics. Okay, now when you talk about hydrodynamics, what is the meaning of that? Think about it. What is the meaning of hydrodynamics? Tell me. Everyone, just think about it, right? For once, think about the flow of liquid around you, right? Okay, I hope all of you have observed this. When you talk about the tap, okay, all of you have observed this, right? When you talk about the tap, okay. Now, when the tap is slow, when the top tap is slow, the flow of water is very smooth. Yes or no? How many of you observe this? Right? Tell me, how many of you observe this? Right? The flow of water is very smooth like this. Okay, this is very big. The flow of water is very smooth like this. This is also very big. Like this. Okay? Yes or no? Tell me, yes or no? Right? if the pressure of water of the tap is right very slightly open, then you will think that okay, water is flowing like one line, one single line, as simple as that, right? It means all the molecules of water are moving in sync, right? Think about it, yes or no? Just try to imagine, yes or no, right? Have you observed this? How many of you observed this? Raise your hand. How many of you observed this? Right? Or you can observe this, right, whenever you want in your home, okay? But when you talk about high pressure, right? Just turn on the tap, okay? Turn on the tap at full. What you will observe? You will observe that the water will come out like this. Sorry. Yes or no? Water will come out like this, right? Yes, agree? Tell me, agree? Think about it. Tell me, guys. Please respond, guys. Please respond. Can you hear me? Am I audible? Then I'm just asking you something, right? Have you observed something like this, right? And if yes, then what do you think? What is the reason behind the difference, right? What is the difference behind the flow, right? When the pressure is less, the flow is very streamlined, right? I can say the word streamlined, okay? But when the pressure is high, okay, or when the speed of water is high, it is flowing like this. So this is not streamlined, right? Got it? Yes or no? Think about it. Yes or no? Have you observed this? Okay. Now, if you think about the flow, so I can say that we have two type of flow. Okay, right? With this example, I can say that okay, I'm having two type of flow, right? Yes. First is steady flow, right? Steady flow. Now you can see the steady flow many times. Okay. I hope all of you have observed your agabatti, right? Your candlestick when it is burned, right? How many of you observed the flame like going like this? Think about it. Then it disperses, right? Then it disperses, right? So till this moment, I can say that, right? The flow of gas is streamlined or steady. Got it? Yes? Agree? Okay. So what is the nature of steady flow? Can I say that, okay, the velocity of, if the velocity, right, is constant, right? If the velocity, what is the meaning of velocity? The speed, or basically I'm saying, right? The speed is, tell me, constant. The speed is constant. Okay, right? Means it is not changing at any point. It is not changing at any point with respect to time. Okay, then the flow is said to be steady, right? Or you can just say that, imagine your highway, right? Imagine your highway, and all the cars are moving at their respective speed, right? All the cars are moving at their normal speed. Okay, right? Maintaining a steady speed means none of the cars have variable speed. Think about it, right? Now, don't you think that it will look like, okay, everyone is going in a sync? Every car is going in a sync? Yes or no, right? Same displacement between two, right? So I can say that, okay, the flow of this car is like streamlined, right? I can say that, okay, these cars are streamlined. Got it? Now what will happen, suppose, right, if they start moving with different velocity, suppose this moves with 100 meter per second, this moves with 50 meter per second, what will happen, right? This will strike this, yes or no, right? Then this car will move here and there, crash and all those things, right? Some car will just jump out of the road, yes or no, jump out of the road, right? They will collide with each other, and the path will not remain streamlined now, yes or no? Just think about it. I hope this thing you can visualize. Now don't think that the same thing should happen with, or the same thing might be happening with fluid also, or water also, right? Any liquid, if all the molecules are moving with same velocity, right? So they are maintaining their streamlined position. But if the velocity is not constant, if it is changing, right, then the path will not be streamlined, okay, right? The flow will not be steady. Got it, everyone? I hope all of you understood the concept of steady flow. Okay, why we are studying this? Because when you talk about the concepts of fluid dynamics, okay, we consider the flow to be steady. Okay, we will consider the flow to be steady, right, everyone? Easy. Okay, now let's see the next concept. Let's see the next concept. Think about it. Suppose I'm having a pipe. Suppose I'm having a pipe like this. Okay, now in this pipe, if I'm like sending 10 liter of water, think about it, sending 10 liter of water, how much water will come out of this end? Think about it. Very simple, very easy question. How much water will come out of this other end? If this is end A, this is end B. Try to think about it. How much water? 10 liters going inside this, right? How much water will come in outside this after time t? Suppose after time t, same 10 liter only, na? Is there anyone who is having this doubt कि नहीं कम आएगा, right? Right? Right, everyone? Anyone have any issue in this? Tell me. Anyone have any issue in this? Okay. Now think about this setup. Okay. Now think about this setup. Now tell me, right? Area of this is equal to area of this. Wait, I'll just draw a better figure. Okay, okay. Area of this is, suppose A1. This is A1 or capital A. This is also capital A, but this is small a. Okay, this is also capital A, but this is small a. Right? Now I'm sending 10 liter from here. Think about it, right? Do you think that the same 10 liter will come out from here? Yes or no? Yes or no? But how slowly? Think about it. How slowly? Because what if at any instant 10 liters at any instant now, 10 liters any instant, if any instant 10 liters, right, 10 liters coming inside, and then 10 liters should come go outside now. Think about it. Yes or no? Think about it. right? Now, my question is, what will happen in this area? What will happen in this area? Because if I talk about the concepts, I can say that okay, if 10 liter is entering in this pipe at any instant, then each point should have 10 liter, right? Yes or no? Tell me. Or should let 10 liter to flow per unit time? Agree? Tell me. Agree? Think about it. Agree? But how this is possible, right? Just ask yourself how this is possible. Can I say that suppose the velocity here is v, right? And velocity here is suppose u, right? Where the velocity will be more, where the velocity of water will be more, u or v? Tell me, u or v? How many of you did this? How many of you played with your water pipe, right? Where you pressed the water pipe and just let this area to be open and the water is coming out with more velocity, watering plants. How many of you did this? Tell me. I guess most of you did this, or all of you have done this, right? At some point of your time. Just think about the practical things that we have done. Okay. So if I think about this, I can say that, okay, right? Since area is less, velocity should be more. And here area is more, velocity should be less. Got it? Tell me, got it? Agree? Right? Everyone agree with this? Because at any point of time, the amount of liquid flowing through any cross section should be same. Okay. I hope this is well understood. This is well understood, right? Okay. Let's try to make this concept in equations. So let's understand what is principle of continuity. Okay, right? What does this principle of continuity says? It says that if we have any incompressible liquid or non-viscous fluid which is flowing in streamline, right? This is just what I said. Then the amount of liquid flowing at any instant, right, will be same throughout the liquid. Yes or no? Yes or no? Right? Tell me. Okay, so I can say that A1 into V1, area into velocity at this point, is equal to A2 into V2, right? I hope all of you understood this, right? I hope all of you understood this according to your intuition, right? According to your intuition. Got it, everyone? Got it? Right? Makes sense, na? Okay, but if I want to prove it, I can prove it easily. It doesn't matter. I can prove it. Okay, how? I'll just do the same thing. As per the definition, I'll try to equate the amount of water flowing through this at any point of time, right? Got it? So which is what? Tell me, amount of water flowing, right, is area. Okay, see, this is the same thing now. The mass of fluid at any time t, delta t. So A1, V1, rho delta t, because A into X. Just think about it now. A X rho, volume into density, mass, is equal to A2 X2 rho. Yes or no? And we know that x is equal to velocity into time, v1 delta t. So a1 v1 delta t rho is equal to a2 v2 delta t rho. Delta t rho, delta t rho cancel. This is the same thing. Got it? I hope all of you understood the concept. Tell me. I hope all of you understood the concept. Anyone have any doubt in principle of continuity? Tell me. Anyone have any doubt in principle in continuity? No? Right? But suppose if we have two different liquids, right? Then instead of rho, we will have rho 1, rho 2. Got it? That's the only thing that will change. I hope all of you understood this. Tell me, right? Okay, but if it is the same liquid, then how can density will change, right? The only reason why the density will change is we are considering the compressible liquid. Okay, right? So I don't think that this will be coming in your exam, but if the concept wise, if you understood, it's better. Okay, right, very good. I hope all of you understood this concept. Okay, right? Tell me, guys. Yes. Anyone have any issue till this concept? Anyone have any issue till this concept? Raise your hand. Archimedes principle and principle of continuity. Right? We have covered two concepts. If anyone have any doubt in these two concepts, please let me know. Tell me, guys, no concepts clear? Raise your hand. If the concepts are clear, raise your hand. Very good. Right? Very good. Your homework, we will just see some concept test, okay, based on buoyancy, right? But I hope all of you know your homework, all the examples of the notes that I've sent, okay, right? Okay, so let's see some concept test. Tell me, guys, what is the answer of this concept test? A wooden block of density rho experience a buoyant force B when it is completely immersed in fluid. What will be the buoyant force experienced by other block of density 2 rho, right? And same dimension, right? When it is immersed in same fluid. Okay, I got two answers. Okay, very good. So, okay, Abhiram, you corrected your answer. Think about it, now think about it. It's easy. Guys, everyone, try to think what would be the answer. Only Ovas and Abhiram answer till now. Shrihari, Anamika, Churika, think about it. Nidhi, Nishita, Samya, Sanya, Tulip, Sumaya. What will happen to buoyancy if the density is 2 rho? Right, let's see the answer. It will be same now. Think about it. Right, it will be same because the volume occupied will change. Yes, very good, Sanya. Right, the volume occupied will change. That's it. That's what will happen. Right? Okay. Very good, everyone. Next concept test. Next concept test. Try to think, guys. Try to think. Everyone, tell me what's the answer. Abhiram, Oves, Shrihari, Pradyuman, Meet, Jasharan, Pradyumna, Akshaya, Amish, Nishita, Pranjal, Priyanka, Riya, Smriti, बताओ. Tell me. Okay. See, it is conceptual, right? Try to solve. It is conceptual. Okay. This will be the last question of today's class. Okay. I got the answer of Oves and Abhiram. I got two different answers. Now, Amish, okay. So I get two same answers, one different answer. Now let's see what will happen. Think about it, right? Apparent weight is net downward weight. Okay. Volume, mass, volume to V, mass M. Okay. Now apparent weight are W1 and W2. I hope all of you remember what is the formula of apparent weight. Tell me. Mg minus buoyancy. Yes or no? Tell me. Yes or no? That is your apparent weight. Agree? Agree everyone? Let's see the answer. The answer is B. The answer is B. Right? How come? See, this is what I told you, right? Think about it. When you talk about W1, it is Mg minus B, right? But when you talk about W2, since volume is twice and both are submerged, right? Then buoyancy will be 2B, na? Yes or no? Tell me guys, yes or no? This was a basic conceptual problem, right? You don't have to calculate a lot, okay? Got it? Right? Okay. So, yes, so you can solve, right? Homework is you can solve HC1 examples and the examples of notes that I have sent. Okay, that's it, right? That's it, the homework. Okay, right? For Wednesday class, right? No, 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 not done, right? We will still have 3 classes more. Okay, one more concept is left, right? Okay, then we will have problem solving of modules and all those things. So we'll have 3 more classes. Okay, this is first topic only, right? According to LMS. Okay, bye everyone. Thank you everyone. Take care. Bye everyone.